Hi everybody, we are doing exercise 1.5 of class 9 NCERT maths, the chapter number systems. Let's get right to it. So question number 1 of exercise 1.5 says classify the following numbers as rational or irrational. And the first part is 2 minus root 5. Now, one of the properties of irrational numbers is that whether you add it or subtract it to a rational number, the answer is always an irrational number. So hence over here we see 2 is a rational number, root 5 is an irrational number. We're subtracting root 5 from 2. This will always give us an irrational number. Now the second part of this question is 3 plus under root 23 minus under root 23. Now the second one, when we simplify this, we open the bracket, the root 23 cancel itself out and we get the number 3. Now just the number 3 by itself is definitely a rational number. Moving to the third part, it says 2 root 7 divided by 7 root 7. Now when we want to simplify this, the root 7 cancels itself out and we are left with 2 by 7. The number 2 by 7 in itself is a rational number. Moving on to the fourth part, 1 by root 2. Now another property of irrational numbers is whether you multiply it or divide it with or by a rational number, the answer is always an irrational number. So in this case, 1 is a rational number, root 2 is an irrational number, 1 by root 2 will always be an irrational number. Fifth one is 2 pi. Pi we know is a unique irrational number. 2 is a rational number. When we multiply the 2, it will always be an irrational number. And that completes all the parts of question number 1. Moving to question number 2, it's asking us to simplify each of the following expressions. The first part is 3 plus root 3 multiplied by 2 plus root 2. This multiplication we get 6 plus 3 root 2 plus 2 root 3 plus root 6. And that's its most simplified form. Second part is 3 plus root 3 multiplied by 3 minus root 3. Now this is in the form of a plus b multiplied by a minus b, and we know that this is a square minus b square. Hence we can write this as 3 square minus root 3 square, which is nothing but 9 minus 3, or in other words, the number 6. And that's the solution of part 2. Part 3 is root 5 plus root 2 the whole square. Now if you remember the property of a plus b whole square is a square plus b square plus 2ab. So using this property over here, it gives us root 5 square plus root 2 square plus 2 times root 5 into root 2, which is nothing but 5 plus 2 plus 2 root 10. Simplified further is 7 plus 2 root 10. That's the solution for the third part. The fourth part is root 5 minus root 2 whole multiplied by root 5 plus root 2. Now again, this is of the form of our equation a minus b into a plus b. This is a square minus b square. So putting this formula over here, we get root 5 square minus root 2 square, which gives us 5 minus 2, or simply 3. And that's the solution for part 4. Now, question number 3 says, recall that the ratio pi is a ratio between the circumference of a circle to its diameter. So which means pi is equal to circumference divided by diameter. And this seems to contradict the fact that pi is irrational. So how will we resolve this contradiction? Since circumference and the diameter are definitely rational numbers, right? So, well, to be honest, no. When for a particular circle, when we measure the circumference with a scale or the diameter with a scale, right, we are finding the closest approximation. No matter how precise you take the scale to be, you can always zoom further and find a more precise location of that point on a particular scale. Now, real numbers as well as rational numbers as well as irrational numbers can definitely be put on a number line and therefore can be measured in the scale. When we are taking the circumference c and the diameter d, we're assuming that we are taking rational numbers. That assumption is wrong. They could be irrational. And we know for a fact that pi is an irrational number. So hence c by d, which is the circumference by diameter, is an approximation and not a rational number. And that is the reason why pi is an irrational number. And there is no contradiction here. Moving to question number 4. It's asking us to represent under root 9.3 on the number line. And how do we do this? So it's fairly simple. There's a bit of construction involved. I'm going to do the rough construction over here. You could use a compass and a scale to do right measurement and it'll turn out fine. However, let me take a line segment. I'll call it AB over here of 9.3 units. What I'll then do is I'll take further construction BC, where BC is 1 unit, right? Now, the midpoint of AC is something I can get using my line bisector construction. Let's say this is the center of line segment AC. I'll call this point O. Now with center O and radius OA or OC, I need to draw a semicircle. Probably if you use a compass to do this, it'll turn out to be a much more accurate representation of a semicircle than my rough hand drawing over here. But nonetheless, now I draw a perpendicular from B, a line perpendicular to my number line AC over here, and see where it intersects the semicircle. This point over here, let me name it D. BD out here is my required under root 9.3. And let's say if I were to extend this line segment further, now let me say that this is a number line. I'll imagine that the point B is 0, the point C is 1. I open my compass with center B, radius BD, which is 9.3, and I project the same thing on this line segment out here. Let me call this point E. Now essentially what I have done is I have extrapolated this under root 9.3 on this number line BE. So my BE becomes under root 9.3. And that's how we represent under root 9.3 on a number line. This brings us to question number 5. And it says, rationalize the denominator of the following. So the first part is 1 by root 7. And we're supposed to rationalize the denominator, which means that we need to make sure the denominator is a rational number. And what we do over here is pretty simple. We multiply the numerator as well as the denominator by root 7 in this case, and we get root 7 by 7. There we go, we've rationalized the denominator. Moving on to the second part. Second part is 1 divided by root 7 minus root 6. Out here, what we're going to do is we're gonna multiply the numerator as well as the denominator by root 7 plus root 6. What this will do is, out here my numerator becomes simply root 7 plus root 6. In the denominator, however, I will multiply root 7 minus root 6 with root 7 plus root 6, which, if you remember, is nothing but the formula a minus b into a plus b, which gives us a square minus b square. So if we do this in the denominator, it gives us root 7 square, which is 7, minus root 6 square, which is 6, and the denominator becomes 1, and hence my solution becomes root 7 plus root 6. Simple enough. Moving to point number 3. This is 1 divided by root 5 plus root 2. Now I'm going to do the same thing as I did in the previous example. I'm going to multiply this with root 5 minus root 2 in the numerator as well as the denominator. What this gives me in the numerator is root 5 minus root 2, and the denominator, I again use the same formula, a plus b into a minus b, which is a square minus b square, and hence out here it becomes root 5 square, which is 5, minus root 2 square, which is 2, which gives me root 5 minus root 2 whole divided by 3. I've neutralized, or rather rationalized, my denominator out here. Moving to the final part of this exercise. The last part is 1 divided by root 7 minus 2. Here again, what I'm going to do is I'm going to multiply the numerator and the denominator by root 7 plus 2. So my numerator gives me root 7 plus 2, and the denominator, I again use the formula a minus b into a plus b, which is a square minus b square, and hence in my denominator I get root 7 square, which is 7, minus 2 square, which is 4. So here I get root 7 plus 2 whole divided by 3 with a rationalized denominator. And that's the solution for part number 4 of exercise 5. That brings us to the end of this exercise. Thank you for watching, and please watch the rest of the exercises in the next videos as well. In case of any doubts or any questions, you can leave a comment below or reach out to me on the email ID mentioned in the description. Thank you.